You're listening to EUAudio. Listen, learn, lead. The final frontier for aerospace manufacturing. The Condor Cluster was a supercomputer built out of 1,760 Sony PlayStation 3s running on the Linux operating system. Built to analyse high-definition satellite imagery, the Condor Cluster was in operation for just a few months before Sony disabled the use of Linux on the PS3, leaving no means to procure functioning Linux replacement units. Product obsolescence becomes a major threat when off-the-shelf products are used to build a system. Aerospace manufacturers can avoid delays in production by managing obsolescence and production correctly. Commercial off-the-shelf products are often used in the design and manufacture of aerospace systems, as they offer access to low-cost alternatives to full, mil-spec parts. However, these products are not specifically designed or qualified for the aerospace market. Now, aerospace manufacturers are turning to more novel technology, such as additive manufacturing, to ensure that all parts used in system construction are suitable for all requirements. Aerospace manufacturers are facing the pressures of a growing market, tight competition, and unyielding standards. The move from standalone machining centres to horizontal centres in automated cells helps free up labour, maximise manufacturing flexibility, and increase efficiency. The number and diversity of components that go into an aircraft, whether it's civil, commercial, or military, is daunting even for experienced industry professionals. The materials used in aerospace manufacturing tend to have more advanced specifications with higher tolerances and extremely strict traceability requirements. Structural components, for example, are normally machined from high-strength alloys, which are resistant in extreme temperatures and light enough to be used in the manufacture of aero engines and airframes. By using horizontal machining centres with chip control capability and rotating pallet control, a manufacturer can minimise cutting and part handling time. Intelligent automation solutions can further increase the flexibility of the process, allowing the same machining system to work on different components. This also ensures better control over workflow and a much faster production rate. Once aerospace manufacturers have begun using automation to improve productivity, they should consider the impact of obsolescence on production. When following a proactive obsolescence management strategy, the aerospace manufacturer monitors the availability of parts as well as taking action to manage obsolescence before a part is discontinued. In general, proactive obsolescence management is a good idea in aerospace manufacturing, as each component is often essential to process or production. If the component does become obsolete, it will be difficult to replace, which in turn could cause costly downtime and delays in production. It would be challenging for any manufacturer to monitor the obsolescence status of every single item in its bill of materials, so components should be ranked in order of importance and appropriate measures put in place. Using data available from the part manufacturer or an independent database, as well as looking at algorithmic and historical data, can enable a manufacturer to predict life cycle changes early and decide on the most appropriate solution. It may be too late for the Condor Cluster, but with a proactive obsolescence management strategy, and by making the most of automated technologies, aerospace manufacturers can ensure that their systems are in use for years to come. EUAudio is brought to you by EU Automation,